All right, let's look at the homework 4.6, problem number 10. All right, it says this. The manager of a factory finds that the maximum number of units a worker can produce in a day is 30. The learning curve for the number of units that N produced per day after a new employee has worked for T days is given by this. All right. So after 20 days on the job, a worker is producing 19 units in a day. So this gives us a clue to find this K value, right? Then we want to find the time it needs for the worker to produce 25 units per day, all right? So let's do that. All right, so let's see. First, I'm going to use this condition. It says that after 20 days, so N of 20, so T is equal to 20, so I'm using this 20 right here, and it's producing 19 units a day. So this is going to be equal to 30 times quantity 1 minus e to the 20k, so 20k, right, is equal to 19, right? So let's solve this equation for maybe e to the k, right? So this is going to be, right, first thing I would do is divide through by 30 so that the 30 is gone. So it's a 1 minus e to the 20k is equal to 19 over 30, right? Then I can subtract 1 from both sides. So you have a negative e to the 20k is equal to, right, so 19 over 30 minus 1 is 11 over 30, right? Then let's see, oh, it's going to be negative, right? Then I'm going to actually go ahead and multiply by negative 1 so that it's going to be positive on both ends. Right? Then I'm going to just simply, let's see, raise it to the 1 over 20th power so that I can get rid of that 20. So you have a e to the k, right, is equal to, right, 11 over 30, raise it to the 1 over 20th power, right? So we found that e to the k. All right, so this gives us n of t, right? So n of t is equal to 30 times quantity 1 minus, this is going to be 11 over 30, and then you have t over 20, right? Then I just need to change that to a bracket. Right, so we got that. Right, so we have complete information of the function n of t. Then we want to find the value of t when this is equal to 25. Right, so I'm going to set that equal to 25. All right, so let's solve for t. All right, so divide through by 30, so we get 1 minus 11 over 30, raise it to the t over 20, right? So you have a 25 over 30, right? And top and bottom is a multiple of 5, divide by 5, you get 5, divide by 5, you get 6. So we have 5/6, right? So we got that. Right, then I'm going to subtract 1 again, so it's going to be negative 11 over 30 to the t over 20 is equal to 5 over 6 minus 1 is negative 1 over 6. Right, again, I'm going to multiply both sides by negative 1 so that they become both positive. Right. Then I'm going to take the natural log of both sides. So we have a natural log of 11 over 30, raise it to the t over 20 is equal to natural log of 1 over 6. Right? Then we can actually put this guy in front. So we get t over 20 times natural log of 11 over 30 is equal to natural log of 1 over 6. Right? Then we can isolate t by first multiply both sides by 20 and divide through by natural log of 11 over 30. That way you're going to have a t by itself, right? So multiply by 20, so you have a 20 natural log of 1 over 6 over and natural log of 11 over 30, right? So let's get this value using a calculator. All right, so we need to compute 20 times natural log of 1 over 6 and divided by natural log of 11 over 30. All right, let's hit enter. All right, so we have 35.7. So this is about 35.7 days. All right, so let's type it in. Oh, not here. 35.7. All right, let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.